We have a quadratic equation x squared plus 2kx plus 2k squared minus 1 equals 0. And they're telling us it has at least one negative root. And so we'd like to figure out what possible values of k we could have so that this is true. That is, for some values of k, this equation might have no roots or only positive roots or something like that. So we want to play around with that to find what are the possible values of k that will give us exactly one negative root. Sorry, at least one negative root. Okay, so first let's make sure we can have roots. So let's explore first the discriminant of this equation, which would be in this case, so b is 2k, so this is 2k squared and minus 4az. Okay, so then we have, this is 4k squared minus 8k squared plus 4, so this is 4 times 1 minus k squared. So if you want to have real roots, we need this to be at least 0, which means 1 minus k squared has to be at least 0, right? Dividing by 4 on both sides, and so we get 1 is at least, at most the value that we can have for k squared, so that is the absolute value of k is at most 1. In other words, k has to be between minus 1 and 1. Okay, so we have some restrictions for k now. Okay, now let's see other information we can get from Vieta's formulas. And so if x1 and x2 are the roots of this equation, we know the sum of the roots is minus 2k, and the product of the roots is 2k squared minus 1. So that is from Vieta's formulas. So note, we don't know much about the sum of the roots, right? Because, we don't know anything about k. And we can try to play around with the product of the roots. So we want to have at least one negative root. That means this product could be negative or positive, right? So that we also are in a little bit of trouble. So let me give you what would be the next step in here, what we could do. So for now, instead of finding the values of k that make me have at least one negative root, let's find what happens when both x1 and x2 are non-negative, so at least 0. So none of these two roots is negative. So when I add them up together, so I am adding two numbers that none of them is negative, so the sum of them will not be negative either. That means minus 2k is greater than or equal to 0, and so that tells me k has to be less than or equal to 0. And we also have the product of the roots, so we multiply two positive numbers, we get a positive number, that is 2k squared minus 1 is at least 0, and so we get then that k squared is at least 1/2, that is, the absolute value of k is at least root 2 over 2. Okay, so we have k is negative and absolute value of k is at least root 2 over 2. So that means altogether k has to be less than minus root 2 over 2. Okay, that is it. We have both roots are non-negative. And so the values of k that gave me two roots that are non-negative would be So k still has to be between -1 and 1 to have roots. So between -1 and minus root 2 over 2. So that means the ones that we have are the ones that are between -1 and 1, but are not in this range. That is, we want k to be more than root 2 over 2 and less than 1. So these possible values of k will give me at least one negative root, if not both. I don't know if both, but I know for sure I will have at least one negative root in there.